Welcome to Alpha Numeric Tricks. In this video, we are going to see the problems under the topic first order nonlinear partial differential equations. In last two videos, we have seen that the working rule to find the solution of standard types of first order nonlinear partial differential equations. Now we are going to see how to get the solution of these two problems under the type f of p comma q is equal to 0. Now we will see one by one. First problem is solve root p plus root q is equal to 1. So suppose after seeing a problem, you have to identify the type of the problem. So we have seen for 4 types of problems already. That is, these are the standard types of problems available in first order PDE, nonlinear PDE. So we have to check it out. That is, which this problem comes under which type. Here P and Q is present in your problem. So in your first type only we have P and Q terms. Okay. So this problem comes under f of p comma q is equal to 0. In this video we can easily say that this is the first type of problem because the heading is given. But when you are doing your exams, it is not possible. So you have to that is, you have to identify this way. Now we will get the solution. First you have to find out the complete integral. How will you find out the complete integral for this type of problem type 1? First you have to assume the assumed solution. You have to write it and then you have to substitute p is equal to a, q is equal to b in the given problem to find out one constant value that is substituted in the assumed solution. Then you can get the complete integral. Now we will see the result. First, before going to start with this complete integral, you have to write the problem comes under which type. So this is of the form, or this problem is of the form f of p comma q is equal to 0. Now for that, once you identify the type, then you have to go for the general procedure available. So first, for this type of problem, first you have to write the assumed solution. So the assumed solution of this given problem is z is equal to ax plus by plus c. Number that equation as 1. This thing you should remember, no other way. Okay, so you have to remember this is assumed solution. And then the substitution you have to do it. That is also you have to remember. Now you have to make use of the substitution. P is equal to A, Q is equal to B in the given problem. Then your problem becomes root A plus root B is equal to 1. Using this relation, we have to find out any one of the arbitrary constants. Why we are doing this is, in your complete solution always consists of 2 arbitrary constants. Because we have in our problem is having 2 independent variables, that's why the complete integral must contain 2 arbitrary constants. But in our assumed solution, we have 3 arbitrary constants. So to reduce one constant, using this relation, you have to find out the another one constant value. Either you can find out the value of A or you can find out the value of B. Both are correct. Okay. So now we are going to find out the value of B. So root B is equal to 1 minus root A, that is plus A is taken to the right hand side. So you have 1 minus root A. From this equation, you have to find out the value of B. That is, when you are squaring on both sides, you can get the value of B. So squaring on both sides, you have B is equal to 1 minus root A the whole square. So we get the value of B. This is substituted in the assumed solution 1. So the equation 1 becomes z is equal to ax plus b is replaced by 1 minus root a the whole square into y plus a constant. Now look at the equation. It contains only 2 arbitrary constants and 2 independent variables. So this is the required complete integral. Now we are going to see how to get the singular integral. Okay, how will you find out singular integral? That is, this is obtained from your complete integral, and this complete integral you have to differentiate the complete integral with respect to the available arbitrary constants, and then you have to use the rule. Now we will see. Okay, so here what are the arbitrary constants available? A and C. So you have to differentiate this complete integral with respect to A and C partially, and using the rule dou z by dou A is equal to 0, that is z is differentiated with respect to the available arbitrary constants and then equated to 0. So dou z by dou A is equal to 0 and dou z by dou C is equal to 0. This is the rule we have to use. This also you have to remember. Now we have to differentiate this equation too, that is your complete integral partially with respect to the available arbitrary constants A and C, but here it is not necessary to differentiate with respect to A. Why it is not necessary is the single, that is the C, the arbitrary constant C is present separately. This is already explained in that is standard types of working rule video. Okay, so have a look on it. Now C is separately there. So when you are differentiating this with respect to C, then you get dou z by dou C is equal to C differentiation with respect to C is 1, but dou z by dou C value which is equal to 0 using this rule. So we get 0 is equal to 1, which is observed result. So there is no singular solution for this problem. Root p plus root q is equal to 1. So in this problem, no need to differentiate this with respect to A. First, for all the problems, when your one arbitrary constant is separately occur, then in that case, just you write this way. It is differentiate with respect to that constant only, and then you get the observed result, and you conclude that no singular integral or no singular solution for the given problem. Now we will see how to get the general integral or general solution. This is obtained from the complete integral. This is obtained from the complete integral, and there you have to reduce two arbitrary constants to single arbitrary constants. Make use of the substitution. C is equal to 5, that is one constant should be written in the function of the other. Here in our complete integral we have ax plus 1 minus root a the whole square into y plus c, that is two arbitrary constants is there. We have to write one constant as a function of another one, and you have to substitute this in equation 2. So it becomes z is equal to ax plus 1 minus root a the whole square into y plus c is replaced by phi of a, or you can use a is equal to phi of c also. Both are true. Okay. Now you have to differentiate. So two constants reduce it to single arbitrary constant. Now you have to differentiate this with respect to the arbitrary constant a partially. Then you have dou z by dou a, which is equal to 0 using the rule again, is equal to differentiation of ax with respect to a is x plus differentiation of that is when you are doing differentiation 1 minus root a the whole square into y with respect to a, y is constant. So write as it is. You have to do the differentiation for 1 minus root a the whole square. What is differentiation of 1 minus root a the whole square? 2 into 1 minus root a into 1 minus root a is differentiated with respect to a. So you have minus 1 by 2 root a, that is root 1 differentiation of 1 with respect to a becomes 0 because it is constant, minus root a differentiation is 1 by 2 root a, but here minus is there. So you have minus 1 by 2 root a into y plus differentiation of phi of a with respect to a is phi dash of a. Number the equation as 4. Now using 3 and 4 eliminate the arbitrary constant a, then you get the general integral. This is the way you have to conclude. Here the elimination of this is not possible, but in a problem phi of a is not given in our problem. If it is given, then you have to go further, otherwise you conclude your problem like this. Okay, that's enough. This is the general rule for the type 1 problem. Root p plus root q is equal to 1. Next we will see the next problem. Solve q plus sin p is equal to 0. Here also the two terms p and q only is present. So this comes under first type of problem. So we have to write the complete integral for this. So this when you're starting the problem, first you write this comes under the type f of p comma q is equal to 0. So how do you get the solution? First you have to write the assumed solution. So assume the solution for this problem is z is equal to ax plus by plus c. All problems under this type you have to do the procedure for complete integral. Okay, so you have to first write the assumed solution. This is same for all the problems. Z is equal to ax plus by plus c. Number that is 1. Now, but you know that a complete integral consists of two arbitrary constants because we have two independent variables is there. So you have to reduce 3 constant to 1 constant. Sorry, 3 constant to 2 arbitrary constant. For that, we have to make use of the substitution. P is equal to A and Q is equal to B in the given problem. This also you have to remember. Okay. Now, when you substituting this in the given problem, B plus sin A is equal to 0. That is Q, A is replaced by P is replaced by A and the Q is replaced by B. So B plus sin A is equal to 0. From that we get the value of B is equal to minus sin A. That is plus sin A. You have to take it to other side. That is right hand side. It becomes minus sin A. We have to substitute in where? That is in your given assumed solution. So the solution 1 becomes z is equal to ax minus b is replaced by sin a into y plus constant c. Now look at the problem solution. You have consists of 2 independent variables and 2 arbitrary constants, so which is where required complete integral. Okay. Now we have to find out the singular integral. Singular integral is obtained from the complete integral as usual, and you have to differentiate this complete integral with respect to the arbitrary constants a and c and use the rule dou z by dou a is equal to 0 and dou z by dou c is equal to 0. That is, when you differentiating z partially with respect to a and c, that value is equated to 0. That is the rule we are using here. Now we have to find out the singular integral. So for that you have to differentiate 2 partially with respect to the that is first here already it is differentiating with respect to c is enough because c is occur separately. So we write differentiating with respect to c alone. Then you get 0 is equal to 1, which is observed result. That is dou z by dou c is equal to 0 is equal to differentiation of ax becomes 0 with respect to c we are doing. Similarly, sin ay is constant, so differentiation with respect to c becomes 0 and c differentiation with respect to c is 1. So we get 0 is equal to 1, which is observed result. So there is no singular solution for the given problem. Q plus sin p is equal to 0. Now we have to find out the general integral. General integral is as usual. You have to write one constant as a function of another one and substitute that is in equation 2. So we have, but what is the equation 2? Z is equal to ax minus sin ay plus c. Equation 2 is a complete integral. So here you have to replace c is equal to 5. Then your equation becomes z is equal to ax minus sin ay plus c is replaced by 5 of a. Number that equation as 3. Now you have to differentiate this equation with respect to the arbitrary constant a partially. Then you have dou z by dou a is equal to 0 is equal to differentiation of ax with respect to a becomes x minus this minus sin, that is y is constant, right, as it is. Differentiation of sin a with respect to a is cos a plus differentiation of phi of a with respect to a is phi dash of a. Number that equation as 4. Now using 3 and 4 you have to eliminate the arbitrary constant a, then we get the general integral. This is the way you have to write in your exams also, because we doesn't know the function phi of a. Okay, that's all for today's video. If you have any doubts in this, please have a that is provided in the comment section. Thanks for your time and thanks for watching. We will see in the next video with some more problems. Thank you.